All right, ladies and gents, this is your 5153 test review. There are some questions that I added to the very end. I also uploaded the answers with the additional questions on there. So make sure you guys refer to that when you're looking at the answers that I already posted and this video. All right, so you're going to have 7 questions on your test tomorrow. You're expected to finish in the time allotted, but there's 7 questions. This review is obviously a lot longer, so don't freak out that you guys are going to have to do this many questions in the class period. You will have one question like these first 3 where you're verifying. Verifying means you're proving that one side equals the other side. Okay, so let's look at this first question. The first step is the hardest. I don't want to just tell you guys what to do because then it kind of makes it like, oh, now it's easy because she told me what to do. Little things to consider. When you see a tangent squared, a secant squared, a cosine squared, a sine squared, and a plus or minus 1, we generally look at our Pythagorean identities. That's a good place to think about starting. So on the left-hand side, do you see something that you could possibly change into something else relatively easily? Yes. What?
1 plus tangent.
Okay, look, 1 plus tangent squared of x is the same as what? Secant squared. So what I'm going to do is I'm going to rewrite this as cosine squared x, and I'm going to replace this with secant squared of x. Now we're trying to prove that the left-hand side equals how much?
1.
Positive 1. All right, so now let's look again. What are our most basic functions, our trig functions? Sine and cosine, right? Is there a relationship between cosine and secant? Yes, what is it?
Secant is 1 over cosine.
Okay, so I'm going to rewrite cosine squared, I'm going to leave it, and I'm going to rewrite this as 1 over cosine squared of x. Everybody with me? What do you see happens? The cosines cross out and leave me with what number? 1. What do I have here? 1. You verified that the left-hand side equals the right-hand side. They're not all going to be that simple, but they're not going to be ridiculously hard where it takes you 25 steps to get there. Yes, ma'am?
Since it's secant squared, without y it's cosine squared.
Correct.
On the bottom?
Yep. All right, let's do this one. Well, I'll do the second one in a second. But what do you guys notice? I see a tangent x and a cosecant squared x minus 1. Do you see the Pythagorean identity?
Yeah.
Cosecant squared x minus 1. Okay, look at your identities. What involves cosecant squared? 1 plus cotangent. So look, I'm going to write this down over here. I'm just showing you where we're looking. So I'm going to say 1 plus, what was it? Cotangent squared of x equals what? Cosecant squared x. Correct?
Yeah.
So I want to rearrange the formula in red to say cosecant squared minus 1. Okay, subtract both sides by 1. So I'm left with cotangent squared of x equals cosecant squared x minus 1. Are these two things the same now?
Yeah.
So I have tangent of x times what? Cotangent squared x, yes, equals our cotangent x. Everybody with me? Okay, now there's 2 ways you can go from here. I'll show both ways so you guys can see. I tell you all the time to break down a sine and cosine if you can. Right? So if we did that, what is tangent? Sine over cotangent. I'm going to get there in 1 second, Emma, because there's 2 ways to look at it. And then, no, you're fine. That's good. What is cotangent?
Cosine over sine.
So it'd be cosine squared over sine squared, right?
Isn't tangent over sine over cosine? Not cosine.
Oh, I'm sorry. I meant to write an S. My bad. So what do you guys notice?
You can cross.
1 cosine crosses out with 1 cosine, right? 1 sine crosses out with 1 sine. So I'm left with cosine of x over the sine of x, which is what? Cotangent of x. Is that the same thing? Okay. Well, Emma just said, well, wait, I see something different. You could also do this. You could say tangent. Tangent's also the same as what? 1 over cotangent, correct?
Yeah.
And we said that cosecant squared x minus 1 is the same as cotangent squared x, correct? So what happens? 1 cancels out, 1 cancels out. I'm left with cotangent of x equals cotangent of x. Same thing. Yes, sir?
Could you do it where you do, like, for the cotangent squared, just do 1 over tangent squared, and then you cross off?
There's always a bunch of different ways to get to the same answer. If you see things differently, that's fine, as long as mathematically they make sense. That's totally fine. That's why, again, it's going to take me a little longer to grade this because I have to go through and make sure you guys follow the steps. All right, let's go to this. Yes, sir. Sorry. Okay, let's go to this one. All right, in the last 2 examples, we had a Pythagorean identity right at the beginning, right? We don't have that here. We don't have anything square plus or minus 1. So I am not going to use a Pythagorean identity right off the bat. If I have a numerator that has a plus or a minus and then just one denominator, what have we done every time we've had this? Separate. So I'm going to rewrite this as cosecant x over cotangent x, right? Minus what? Sine x over cotangent of x. Now let's just simplify each fraction. What is cosecant the same as? Okay, so this is 1 over sine of x over, what is cotangent the same as? Cosine x over sine of x. You guys agree with me? Okay. Minus, let's do the other one. Sine x over cosine x over sine x. Everybody okay? All right, now let's just simplify the left-hand one, the black one. Keep, change, flip, yes? So 1 over sine of x, whoops, times what? Sine x over cosine of x. What happens? And I'm left with? Correct? Okay. Now let's go to the other one. I have sine x over 1 times what? Sine x over cosine x. Yes? Okay. Well, what am I left with? Sine squared x over cosine of x. Same denominators? Okay. So can I rewrite this as one denominator? 1 minus sine squared x over cosine x? Anybody see anything? What's 1 minus sine squared same as? Good. So this is the same as cosine squared of x over cosine of x. Anything else? I can cross off one of the cosines. I'm left with the cosine of x. Is that what we started with way up here? So we're good. Now at this point, cosine you said was the same as what, Franco? Here you said secant?
Oh, yeah,
Okay. I wouldn't do that yet. I'd keep everything in sines and cosines till the very end because you could have changed this if you wanted to. This is the same as 1 over secant, right? Could I rewrite this as 1 over secant? Yep. It's an extra step that you don't need, but it's still equivalent. But you guys will have one of those. Every single version of the test will have one of those where you guys have to do this. If this still confuses you, I'd start on number 2. Go do 2, 3, 4, 5, 6, 7, come back to 1. Don't waste too much time on this problem if this just doesn't work for you guys, okay? All right, next one that we're going to look at. Can I move this? No. Can I move it now? Yes. All right, on your test, you guys need to be aware that there are going to be 2 types of questions. There's only going to be one that says find all the solutions. The rest of them are going to give you over the interval of 0 to 2 pi. What is the difference there? If I say all the solutions, what do I have to put at the end of my answers? Plus 2k pi or plus k pi, right? This is for tangent and cotangent, and this is for sine, cosine, and their reciprocals. Correct? That's only when it says find all solutions. If they tell you, like in later examples, only over the interval of 0 to 2 pi, you don't have to worry about writing those things. So I just want to show you that. I'm going to go through these relatively quickly. If I skip one and you guys want me to do it, I'll come back to it at the end. But I just want to make sure we hit on every type of problem that we're looking at. So guys, we're solving. We are solving. I want to get the tangent of x by itself. Solve an equation like you normally would. What do we do? divide by root 3. So I have the tangent of x equals, do I leave that as 1 over root 3? I have to rationalize, right? So I want all the values on the unit circle where tangent is root 3 over 3. Guys, that's not on the unit circle. You have to figure out the ordered pair that gives you that value. You remember that? The ordered pair that gives you that tangent is where radical 3 over 2 is your x value. If you don't know that, you would have to work it out. Say 1/2 divided by root 3 over 2. And then keep, change, flip, and all that. But I want all of the places on the unit circle that's going to give me a tangent of positive root 3 over 3. So it's going to be where and where? Pi over 6 and 7 pi over 6. Does everybody see that? We're good. Okay, so then I would write pi over 6. Sure. I'm going to write x equals pi over 6. And what did you guys say? And 7 pi over 6, right? Since they didn't tell me over one specific interval, and this is tangent, what do I have to write at the end? Plus k pi. Now remember, guys, with tangent, you're always going to cross something out, because what happens from here to here, when I add my k pi, I end up at where? The exact same answer. So what I suggest you do is write your answer like we did, and then just cross one of them out. In this case, it doesn't matter because there's only 2. Yes, sir?
So if we were to leave both, you'd take off points?
I don't know. I'll talk to Ms. Perez. I'll talk to Ms. Perez. Just try and get in the habit if you can. Yes, sir?
What was the order again?
All right, let's look at the next one. Similar question to one that we had on our notes and stuff. I have sine on this side. I have sine on this side. When we solve an equation, guys, we want all of our like terms to be on the same side, correct? So what am I going to do?
Add 2 sine.
Okay, add 2 sine to both sides. So plus here and plus here. So I have 4 sine of theta plus 4 equals 0. Now what? Minus 4, perfect. So 4 sine of theta equals negative 4. Divide both sides by 4, and you get sine theta equals negative 1. What is that telling you?
But the y values.
You're going to the unit circle, and you're looking for where the y values are what? Negative 1. So go to your unit circle. Where is the y value negative 1? 3 pi over 2. So you would say x equals 3 pi over 2. Did they give me a specific interval to look at?
No.
No. That means what do I have to put at the end? Plus 2k pi, since this is sine. If they gave you between 0 and 2 pi, then you don't have to. You just leave it as 3 pi over 2. That makes sense? You okay? Probably have like 2 of these little solving ones. Oh, God. There's only 7 on the test.
How many of the other ones before that?
Verifying?
Yeah.
1.
Oh, if you get one wrong, you could.
No, there's lots of partial credit. It's going to take me a minute to do this. All right, let's pretend they said in this case, and on the answer key I did it different, but between the interval of 0 and 2 pi. What does that mean for your answers? You don't have to put the plus stuff, okay? So let's just pretend that's what these questions are asking. How would I solve this? Well, how would I get this all by itself? I'm going to, what? Okay, I'm going to subtract 3. So I have tangent squared of x equals what? Positive 1. Now I take the square root. Guys, when I put the square root on, what do I put in front of my answer? Plus or minus. Now in this case, guys, I am going to find on the unit circle where the tangent is both positive 1 and negative 1. How many answers am I going to have?
4.
Well, let's look on our unit circle. Where, in the first quadrant, where am I going to get tangent of 1? A pi over 4, right? All right, where else can I get positive or negative 1? 3 pi over 4. Where else? 5 pi over 4. Where else?
7 pi over 4.
Did they tell me one specific interval that we're talking about?
What about like
That won't give you 1. It'll either be 0 or undefined. Because it's the x over the y. Y over x.
For -1, 0 without. Oh yeah, no wait.
No, because it'd be 0 over -1. Yeah. That's okay. Don't apologize. So guys, how many answers are we going to have here?
4.
4. I'm not going to cross any of them out because they're not telling me, oh, just worry about, any time around the unit circle. They're saying only this one specific interval. When does it happen? It happens how many times? 4. So you would tell me your answer was x equals, read them to me again. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, you can write your answers this way. If you guys want to write x equals pi over 4, x equals 3 pi over 4, x equals, it doesn't matter, that's fine. Yes, ma'am.
This is only for if they give you an
Correct.
like it's all the answers.
Correct.
So the intervals you have to
You got a textbook.
And you would add and then cross off the last two. All right, let's look here. Oh, I skipped this one. I'm sorry. Here we go. Let's look at 6. How do I get tangent squared of x by itself? We're going to add 3. So I have tangent squared x equals 3. Now what? Take the square root of 3. So I'm looking for on the unit circle where the tangent of x is plus or minus root 3. Guys, which ordered pair gives you plus or minus root 3?
Is that a half?
It is. The half is first. 1/2 comma root 3 over 2. It would be really helpful if you could commit that to memory, but if you don't, not a huge deal. You just have to work it out. But if you could commit that to memory, it'd make your life a little easier. So go to the unit circle, and I gave you guys a specific interval, right? Okay. Let's pretend we're still given a specific interval. Tell me all the places on the unit circle where the ordered pair is 1/2 comma root 3 over 2. Pi over 3. 2 pi over 3. 4 pi over 3. How much? Is it 5 or 7?
7.
1/2 comma root 3 over 2. 1/2. So it's here, here. Yeah, 5 pi over 3. It's okay. That's why we stopped to look. You with me? We good? Okay, let's do this. This is very similar to another one we did. Yes, sir?
Isn't it the opposite? Isn't it when it's the root 3 over 2? Like,
Do what? Oh, was I not recording? I'm off today. Let's do it again real quick. Because I forgot to hit record. Thanks, Lonnie. So we're going to end up with 4 cosine theta plus 2 equals 0, right? Subtract 2. So 4 cosine theta equals -2. Divide by 4. And we have cosine theta equals -1/2. So what is this telling me to do? Where am I looking? X values are -1/2. You guys are going to be given the unit circle, so just take your time and make sure that you're looking at the right things. Where are my x values -1/2? 2 pi over 3, 4 pi over 3. Does everybody agree with Franco? Okay. If I did not give you the interval, I just said all the solutions, what would you put at the end of each of those answers? Plus 2k pi. Good. Good, good, good. All right, now we're going to do these, guys. These are exact same questions, the exact same thing. There's one little difference at the end. This is a multiple angle, meaning I don't just have x, I have a number in front of x. So in this case, we want to get the sine of 2x by itself. So we would do what first? Divide both sides by 6. So you have the sine of 2x equals 1/2. Did they give me an interval that I'm looking at? Yeah. Yes. So that means I don't have to put anything at the end of my answers. What is sine? Y values. So what you're doing is you're looking for the y values on the unit circle that are positive 1/2. Can you guys please tell me what those are? So pi over 6, yes? And 5 pi over 6. Now, this is not x equals. It's what?
2x.
2x. So watch. When I write this, guys, 2x equals, 2x equals. You will have one of these on your test. The last step you have to do is get x by itself. You would end up dividing by 2, correct? When you divide by 2, you keep, change, and then what? Flip. So you're left with pi over 12. Same thing here. 5 pi over 6 times 1/2 becomes 5 pi over 12. We good? Guys, what happens, this is not the answer, but what happens if it came out to be 4 pi over 12? Would you keep it like that? No, you would simplify. This is a fraction. You always simplify, so you would simplify to pi over 3. That's not the answer. I'm just saying always simplify. Yes, ma'am?
How many questions like that?
1. It's not a super long test. All right, same thing here. I want to get cosine of x divided by 3 by itself. So what do? Divide everything by 2. So cosine x over 3 equals negative root 2 over 2. Don't do anything with that 3 yet. Cosine is what value? X. Where on the unit circle are the x values negative root 2 over 2? 5 pi over 4, 3 pi over 4. Does everybody agree with Franco?
Yeah.
Okay. I'm just going with what you're saying, kiddo. Now, in this case, I'm not going to divide by 3. I'm going to do what? Multiply both sides by 3. So I have what? 15 pi over 4 and 9 pi over 4. We good? Everybody okay? All right, let's look at the last one. It's the exact same kind of problem, guys. You're solving an equation. If I want to get cosine 3x by itself, I would do what? Minus 5. So 4 times the cosine of 3x equals 2. Divide by cosine 3x equals 1/2. Tell me what cosine is. X values. So go to the unit circle. Where are my x values? Positive 1/2. Pi over 3 and 5 pi over 3. I'm not going to say x equals. I'm going to say what? 3x. Good. So in order to get the x by itself, divide by 3, divide by 3. So this becomes pi over 3 times, when I say 3 over 1, reciprocal is 1/3. So that gives me pi over 9. 5 pi over 3 times 1/3 gives me, perfect. One of those multiple angle questions. We good? All right, let's look at some factoring. Done. You're going to have one of each of these types, guys. Just make sure you pay attention to what the question is asking and how they're asking it. And I'll show you what I mean by that in a second. But here they're asking us to solve. That means to find an answer. They gave me an interval, yes? So do I have to put anything at the end? No. This is a factoring problem. This is a quadratic. Are my trig functions the same? Yes, they're both exactly the same. Okay. How can I rewrite this algebraically so it looks easier to solve? 2x squared minus x minus 1 equals 0. Okay, this is a basic algebra problem that we know how to factor. A is not 1, correct? So 2 times negative 1. What's 2 times negative 1? Negative 2. What are the factors of negative 2 that multiply to give me negative 2, but add to give me negative 1? X minus 2, x plus 1, correct? Guys, in every single version, I'm not just going to give you a basic quadratic where a is 1. I have to account that 2 is in front here. So I have to divide both terms by 2. Do you see how I am left with x minus 1 here?
Yeah.
Does 1 divide by 2? No, so it becomes 2x plus 1. Any way that you were taught to factor when a is not 1, you can do. If you know a different way, then do it a different way. Yes, ma'am?
So if it was going to become a fraction, just multiply it to the fraction.
You just move it to, yep. So now, to solve, yes?
I was amazing my hand. I'm just confused.
Okay, well, I'll come back to you, Gigi. Hang on one second.
Okay.
What do I do now? Because I have to know where to look on the unit circle. How am I going to figure that out? What do I have to replace the x with? The sign. This is really sine x minus 1 equals 0, and 2 sine x plus 1 equals 0. So sine of x equals 1. Sine of x equals negative 1/2. So where is sine? Y values, right? Yeah, I moved the 1 over. So I'm looking where the y value is 1 and where the y values are negative 1/2. What are those answers? Pi over 2. 7 pi over 6, 11 pi over 6. You guys agree? Okay. When you factor when the trig functions are the same, it's just a normal factoring problem. Do you have to do this step where you replace it? No. I just think it's easier to see, but that's totally up to you. If we have one like number 14, how would you solve this? Okay, add 3 to both sides. So 12 sine squared of x equals 3. Divide both sides by 12. Yep. Sine squared x equals 1/4, right? Now what? When I put the square root on, plus or minus 1/2. So how many answers are you going to have here, guys? 4. There's 2 times when the y values, since it's sine, are positive 1/2, and there's 2 times when the y values are negative 1/2. I was given an interval to look at, right? Remember, if you're given an interval, we don't have to add the plus 2k pi. So where on my unit circle am I going to look? Pi over 6, hold on, 5 pi over 6, 7 pi over 6, and 11 pi over 6. We okay? Yep. No, you're fine. All right, I'm going to skip the last one because it's redundant. It's the same. These are the ones where you guys are like, oh my gosh, these are so hard. Why are they so hard? They're not the same. They're not that they're so hard. It's one extra step, and then it's just a lot of algebra that goes with it. But I told you guys. Okay, did they tell you here over a given interval? Yes or no? In the following exercises, use an identity to solve. Did they say over a given interval? No. So then what would I put at the end of my answers? Plus 2k pi, because they're all sines and cosines. I'm not super worried about that right now. I want to focus on this. What did I tell you guys? Yes, ma'am. Okay, what did I tell you guys? When I have a quadratic that has 2 different trig functions, change it to the 1. That's which one?
The middle one.
The middle one. Perfect. 98% of the time, for what we're doing, we're going to use this trig identity. Do you guys know what I mean by that?
Yeah.
Sine squared plus cosine squared. All right, so I want to change the sine to cosine. What would I do? I'm going to subtract the cosine from both sides. Do you guys see that? So instead of sine, I'm going to write 2 times 1 minus cosine squared x plus 3 times cosine of x minus 3 equals 0. Do we all have the same trig function now?
Yeah.
All right, now it's just algebra. What do I do with the 2? Multiply it. So 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Do I have any like terms? 2 and the 3. So I'm left with negative 2 cosine squared x plus 3 cosine of x minus 1 equals 0. Same trig functions?
Why does the 2, when you multiply it out, stay on the outside?
What?
You
This one out here?
2 times.
2 times 1 is 2.
Oh, and then.
And then 2 times negative cosine gives you that negative 2 cosine, yep. All right, rewrite this as an algebra problem so it looks prettier. Negative 2x squared plus 3x minus 1 equals 0. If I told you guys to factor this, you would not leave that negative. What would you do? Switch all signs. You're just going to divide it out. So you're going to have, I'll come up here, 2x squared minus 3x plus 1 equals 0.
If we don't do that step,
You could still factor, but it's going to be harder.
So bring out the negative.
I would. 2 times 1. What are my factors of 2 that multiply to give me positive 2 but add to give me negative 3? 2 and 1? Okay, so x minus 2, x minus 1. Can I just leave it like that? Is there a step I'm missing? Gigi, do you see how there's a 2 in front of that x squared?
yeah.
Okay, so that means, because if I multiplied right now x times x, I wouldn't get 2x squared, I would just get x squared. So this is factoring when a is not 1. I don't know how you guys were taught to do it. I personally, when a is not 1, I just take that number and I put it under both factors. And if it divides out pretty, then you took out the GCF, and if it doesn't, it just becomes the coefficient. Meaning, 2 divided by 2 is what? 1. So that leaves me with x minus 1. And then, can I divide 1 and 2 nice and pretty, get a whole number?
No.
So then just move this to the front, becomes your coefficient. You do not have to do it that way. You can do the guess and check where you put a 2 in the front of one and not in the other. Whatever, it doesn't matter. I'm not teaching you guys how to factor. Whatever you're comfortable with. Now we're almost done. This is a long problem. I'm only going to give you one of these. There will be one of these. But what would I do now? Change the x's back into what we started with, cosine. So I have cosine x minus 1 equals 0. And 2 cosine x minus 1 equals 0. Right?
Don't you have 3? Because you took out a negative 1.
But negative 1 wouldn't, you could say
Oh, 'cause it equals-
negative 1 equals 0. It doesn't happen. Yeah. Good thinking though. So this would be cosine x equals 1. Cosine x equals positive 1/2. Cosine, what value? Where on the unit circle are my x values positive 1 and positive 1/2? X equals 0, pi over 3, and now if they said over the specific interval of what, there's my answers. Did they tell me the specific interval? So then what goes at the end of each? Yep. Okay, if we have time at the end, I'll come back and do the other ones. If not, they're worked out on the review that I posted, so you guys can look at that. It's the same exact process. You change to the middle one and then just multiply and factor and all that good stuff. Okay, these next ones I want to bring to your all's attention. You don't have them on your paper right now, so if you want to take a picture of it, or it's on, if you want to just write it down, this is downloaded, or I already uploaded, I'm sorry, onto Canvas. But I want you guys to take note. There's going to be 2 questions like this. One of each. One that says factor, one that says simplify. But I want you to see how these are a little different. Do you see an equal sign here? No. They're not asking you to solve this and look on the unit circle and tell me where the answers are. All they want you to do is what? Factor. This is from the first section. They just want you to factor. So tangent squared of x minus 16. That's the same as what algebraically? X squared minus 16. Agreed? What would that factor into? X minus 4, x plus 4. So how would you write your final answer? Tangent of x minus 4 times tangent of x plus 4. That's it. There's no equal sign. They didn't say solve over the given interval. They just said factor it. That's you factoring it. Do not go beyond that, because you would not find a place on the unit circle where the tangent of x equals positive or negative 4. Just asking you to factor. In this case, is there an equal sign? The direction says to factor. This is the same as 25x squared minus 9, right? 25x and 9. 5 and 5, 3 and 3. So you would have 5x plus 3, 5x minus 3. I wouldn't leave it as x. I would replace x with what? So 5 sine x plus 3, 5 sine x minus 3. That's it. Yeah. Sure. There's no solving. We okay? All right, last ones, then we're done. When it says to simplify, guys, if you simplify your life, you make it what? Easier. Some of us aren't good at that. But you're not verifying that one side equals the other side. You're just trying to make this smaller. So when I first look at this, and I think, oh, yeah, where do I start? What do you see? 1 minus something squared. So that's got to be some sort of a Pythagorean identity. So where does that fall? What has a secant squared and a 1? 1 plus tangent? Agreed? Okay, so over here I'm going to write 1 plus tangent squared theta, or x, equals, what was it? Secant, okay. So I want to manipulate this formula in blue so it looks like 1 minus secant squared. Now think for a second, guys. If I subtract 1 from both sides, just watch, minus 1, minus 1. I have tangent squared of x equals secant squared x minus 1. Are these two things the same thing? No. Hang on one second. 1 minus 3 and 3 minus 1. Two totally different things. You can't just switch it just because you know it's not right. Are we close? Yes. Yes, that means we're on the right track, but that's not exactly what we need. Grace, did you have a question? Yeah. Okay, you want to tell me? Yeah. Okay, good. Hang on. What do you want to tell me?
Do you just subtract the secant and then you put the tangent over?
Okay. If I subtract secant, right? 1 minus secant squared x plus tangent squared x equals what? 0. Okay. Subtract tangent. Good. Now some of you are like, oh my gosh, that's kind of like the same thing we just did. Kind of like, and not exactly, because what does 1 minus secant squared x equal? Negative tangent squared, not positive. So when I go to simplify this, I'm going to keep tangent squared on top. What is wrong? Tangent squared x over negative tangent squared x. Well, what do you guys notice? You can cross them off, and what are you left with? Negative 1. Very different from positive 1. You guys see that? All right, let's look at this one. This one looks complicated. It's really not. We got some multiplication. We got a subtraction. Do you see something squared minus or plus 1? No. So we don't need an identity. Do you notice the two functions that we have? Are they related to each other somehow? Yeah. Are they? Well, you're right. Yeah, be confident. What's secant the same as? Okay, so could I rewrite this as cosine x times 1 over cosine x minus cosine x, like this? Yeah. Everybody see what I did? Yeah. All I did was just replace secant with 1 over cosine. Now what do you think we should do? We're going to distribute. We're going to multiply. We can't just cross stuff out yet because we got that minus sign. So if I multiply, I get the cosine of x over cosine of x minus what?
Minus cosine squared.
Minus cosine squared of x. And that's over 1, right? Okay.
And then just cross off.
Well, what happens with cosine x over cosine x?
They cross out.
It becomes 1 minus what?
Cosine squared x. And then you look at your Pythagorean identity.
And then I look at my Pythagorean identity. 1 minus cosine squared is the same as? Sine squared x. Good, Franco. You guys with me? All right, one more and then we're done. Okay, what happens? What happens here? Do I have a Pythagorean identity because I have a squared something and a plus or minus 1? No. So when we have a numerator that has an addition or subtraction sign and one denominator, what did we do? Every time we had one of these situations, what did we do? We separated them. So I'm going to rewrite this as the tangent x over cotangent of x. Do those things have something in common?
Yes. Cancel now right now.
Yes, you can't yet. Plus cotangent x over cotangent x, right? Okay, now that I've separated it, what is real easy to simplify? Cotangent.
If there's a plus sign.
Yep. So this becomes plus 1. Agreed? All right, now there's two ways you can do this. What are the simplest trig functions that we have? Sine and cosine. So I always like to go that route. So tangent is going to become what? Sine x over cosine of x. Divided by what? Divided by cosine x over sine x. Agreed?
Yes.
Okay. And what do I still have at the end? I mean, to the right. I still got that plus 1. Don't forget it. There's still a plus 1 there. So, what did you tell me, Dallas? Keep change flip. Perfect. So, I'm going to keep sine x over cosine x. Change to multiplication. And then when I flip, what do I get? Sine x over cosine of x. And I still have plus 1, right? Okay. So if we multiply, guys, sine squared x over cosine squared x plus 1. What's sine over cosine? Tangent squared x plus 1. I have a Pythagorean identity. It's secant squared of x. Yeah. Hold on. Yes, sir.
When you had the tangent x...
Hang on one second. You're fine. You're fine.
When you had the tangent x over cotangent x, couldn't you just turn the cotangent
Yep.
into 1 over tangent?
That's what I was about to do.
Oh, okay.
If at this point right here, I'm a creature of habit. So as soon as I see tangent and cotangent, I'm like, oh, sine and cosine. Could we have changed this into something else? Yes, correct? Because tangent, you could do either way. You could have left tangent, right? And then what could you have changed cotangent into? 1 over tangent, correct?
Yeah.
So here, if I did keep change flip, I'd have tangent of x times what? Tangent of x, which gives me tangent squared x right there. Is that shorter?
Yeah.
Yes.
Would that be our final answer then? And we would get it right?
Then you would change it. You'd come to this point, the tangent squared of x plus 1, and then you would have to change it to secant. Always want to simplify. You always want to make small. But again, there's not just one way to do this. Everybody's mind, thinks differently. So, all right. So are we okay? We feel a little better? 7 questions tomorrow. I think you guys are going to do fine. Again, if you get stuck on those verifying ones, if you just look at it and go, oh my God, just go to number 2. Do the whole test and then come back to it. You're going to have partial credit all the way through these ones. So as much as I can give you, I promise I'll try and find it. Good?
Yeah.